Hello students, in the last lecture we have discussed about Gauss theorem. Here we are going to study application of Gauss theorem. The very first application of Gauss theorem is electric field intensity due to infinite long plane sheet. What is that? Electric field intensity due to infinite long plane sheet. Now here we are considering a plane sheet having surface area capital A. Let Q be the charge over the surface of it. For the infinite long plane sheet, we should have in our mind that it would have two of the surfaces. Like I'm taking this as a page, as a book, you can take that. It is having two of the surfaces, one this one and second one is this one. So it would also have two of the surfaces like a page. So here what we are considering a Gaussian surface here in which we are taking a small area ds. Let E be the electric field which is acting outward. Now the electric flux through this particular infinite long plane sheet is given as d phi is equal to E dot ds plus E dot ds. Here E dot ds plus E dot ds, I'm repeating it again, why it is having two of the surface, that is where we are taking E dot ds plus E dot ds. Now d phi is equal to 2 E dot ds. As we can see here, we know that A dot B is written like AB cos theta. Here it is written like E ds cos 0 degree. Cos 0 degree just because it is acting on the surface. Now this implies that d phi is equal to 2 E ds. This can be equation number 1. Now moving further, but the total flux due to this sheet is given by that we are going to integrate it. If we are taking a small area and we are going to integrate that, it would become the total surface area. So here what is that? Phi is equal to surface integral of d phi. That becomes, we are putting the value from equation number 1, that is 2 eds. Now 2a is a constant term which is coming out, that is 2e surface integral of ds. But we have what we have. Since we are having that surface integral of ds can be written like A, because the total surface area we are considering that capital A. This can be considered as equation number 2. But from Gauss theorem we know that phi is equal to Q upon epsilon naught. That is by equating equation 2 and 3, what we are getting, that 2EA is equal to Q upon epsilon naught. That can be written like E is equal to Q upon 2 epsilon naught A. But we know that Q by A is written like sigma, which is known as surface charge density. So what is the result? That is E is equal to sigma upon 2 epsilon naught. But remember one thing, if it is for finite long plane sheet, then it would have only one surface and there would not be any two. And in the result, what would be there? There should not be two. What would be the result for the finite one? That is E is equal to sigma upon epsilon naught only for just one side, for the finite